Okay, very quickly, we're just going to go over a couple of examples that would be, one is an old that we've been talking about. Then this is new material. We start talking about acids as well. So when you see the terminology like this, that's probably easier than having to name the compound, because here you have the compound, you need to name it, and sometimes we give you the name, so all you have to do is draw it. So when we reverse engineer this, we want you to look at some of the suffixes and the prefixes that we see. So for all three of you that are in here, okay, what is the first thing that stands out in your mind, whether you are naming a compound or in this case, what is probably the most important aspect besides knowing that this is an acid? Because when you name compounds, what is the very first thing that we want you to recognize? You need to find the longest continuous chain, but what does that tell you when we see this? So what is the most important aspect, again, besides just seeing acid? How do we know what our parent chain is? Yeah, because if this was hexanoic acid, well then how many would we have? There would only be 6. But since it says heptanoic acid, we know how many carbons are in that chain. There's 7 in there, okay? So we will just do this. I should still be within the frame. Yep. Okay. So now there's, let me try that again. So now here is our 7 carbons according to this, okay? This is telling you something specific then too, because that is your organic family. So according to yesterday, it just says this in your note guide. Okay? Because COOH means acid. So one of the things that you can do is, oh, that's the old one. One of the things that you can do is problem number 1 here. Is that an acid? On your paper here. Is number 1 an acid? No. It is not. Number 1 is a what? It's an alcohol. Okay? So then as we look at page 2, it just says pentanoic acid, which is problem number 4, but that just puts us in the same predicament here. So nothing on page 2 can help us, problems 4 through 7. What about when we look at problems 8 through 11? Can that help us? No, it cannot. But what is significant about problem 16? There is a double bonded what? Oxygen. Okay, so this is just a different way of writing that structure. So I want to ask you, is left side or right side? Okay, so then on our right side, we're going to put this structure here. Here is our double bonded oxygen, like number 16 shows you. And then here is your OH. So that's where this terminology comes from, COOH. So now we know we're dealing with an acid. So what about the bonding between these carbons now? Is anything double bonded throughout the rest of the compound? You're shaking your head no. That would be correct. So all of these are single bonded. Then the last thing we need to do is go ahead and put all of these bonds on here. That's bothering me. Almost makes it look like an E. Gesundheit, Gesundheit. Okay. So right now we would have heptanoic acid, but that's not what this compound says. Okay? It says something specific about carbon number 2. Okay? So it says 2-ethyl. Okay? So if we put an ethyl group on here, there's two ways you can do that. You can use the molecular formula, although this isn't an ethyl group. We could change that to this, because then we can see what it is we're referring to. These two mean the same thing. This is a molecular formula. That's a structural formula. Both of those are the same types of derivatives. So then when you look at this on your second carbon, would you like the molecular formula or the structural formula? Okay, so we can put the molecular formula. And how many carbons would that be? How many carbons would that be? Okay, so here's our 2 carbons. So how many hydrogens do we need for that? Why can't we do C2H6? Yeah, that would be ethane. Remember, this is a carbon-to-carbon bond. It's not a carbon-to-hydrogen bond. Because everything else where we see these dashes, what are these dashes telling you? That there's what type of atoms on? Those are all hydrogens. Now, for our purposes on just practicing on naming these, this could be a little tricky because how many carbons are in our parent chain? Okay, but what happens if we do this? We get how many? Typically, we say your longest continuous chain is your parent chain. That's true of alkanes, alkenes, and alkynes. But this is neither one of them. This is showing you what your organic family is. And our organic family is a what? It's an organic acid. Okay? Because if we did this, we don't know what to name this at all. Because this has to be your first carbon. Because this is showing you what your organic family. So you could put this COOH over here. That's why we said left side or right side. We picked the right side, which is fine. So we can do that because these compounds can be read right to left as well. So now we've accounted for everything. Because, again, when we look backwards, this is telling you that you've got 7 carbons in your parent chain. So that's all of these right here. This is telling you that you have this structure here, COOH, which we've accounted for that. This is saying that you've got C2H5, an ethyl group, and that's located right here, and that ethyl group is located on which carbon? On the second one. So that's how you would write that. Okay. Questions on acids? Yes?
What does the vox mean on the end of it?
This is just telling you this is the suffix for what acid means.
What is the suffix for
That would be OL. That's right. So the question was, what does this mean? OIC is your suffix, just like what we would see here. Okay? That's a suffix. That's telling you have an alkane. This is also a suffix. That's telling you have an alkene. And we've seen this before. This is your suffix. That's telling you have an alkyne. So single bonds, I guess it's not a sin, so we better put a G on here. And we're not singing either, but that's what we mean, okay? So single bonds, what does this mean? So that means a double bond. And what does that suffix mean? Yeah. I'm feeling lazy. I could just put the LE on there too. This might trip you up with this triple bond. I don't know. So then what happens is if we see this, oops. I'm going to try to keep this under 11 minutes, so I better hurry. I don't think that's going to happen. So this is ethanol then. So therefore, our suffix then is OL, and that's what that's referring to there. Okay. Can we erase this content up here? Back row, are we on the bus? Front row? Yes.
So do you have to put like ethanol alcohol or no?
Nope. You just write ethanol because this means alcohol.
So do you have to write out acid with it?
You do have to write acid for that. Yes. Yep. Okay, so let's go ahead and get rid of this so don't get confused by that. So then the compound in blue, okay? Just like every other time, what is your longest chain, even though it's this type of a structure? How many sides does it have? Okay, so what's the prefix for 8? Okay, and we can put that on here because at each intersection, there's a carbon atom, and each carbon-to-carbon bond is single. So that's why we can put ANE, because it's single bonds. So then there's something specific we need to put in front of that octane. Put them over here, because we're going to need all that space. Because this is not a straight chain like we saw with that heptanoic acid. It's not a branched chain. It's a what type of structure? What is it's a ring structure. So when we talk about ring structures, what prefix do we need? You know it. You need cyclo. Okay? That's right. And I understand you have two O's next to one another. So that's cyclooctane. Now, we've accounted for everything here. Now, is there anything branching off of that cyclooctane? Look, there's a chloral group, that's right, not an ethyl group. These are not ethyl groups, methyl groups. So sometimes what helps is just do this. Now you know that that's a methyl group. Of course, you can put a C here, but we already know that that's a chloral group because that helps us with alphabetization. So, what is your goal on the golf course? Get the lowest possible score. So we want the lowest possible numbers that we see here. So the lowest possible number that you can get on any hole is what? A hole in one, or just one. You ever gotten a hole in one? Me neither. It might take some people a lifetime, and I probably won't get one either. So we want a 1 somewhere. But as far as, remember, we said alphabetization, which one of these is going to come first? Why? You're right, but why? Yeah, because C comes before M. So what number of carbon is that chloral group on? It's on our first. And we do have to write 1 on there for that. Then, are we going to go counterclockwise or would we go clockwise? So, okay, so we're going to go clockwise, which means, again, this one's number 1. So here's 2, 3, 4, 5, 6, 7, and 8. But what happens if we go counterclockwise? Then we've got 1, 2, 3, 4, 5, 6, 7, and 8. I should put this one on the inside as well. So we've established that. Okay, and we can have 1 out here as well. So where are we getting lower numbers? 1, 4, and 6. But what happens if we go the other direction? We've got 1, 4, and 6. Okay? So sometimes it just does not matter. Okay? And that's just a coincidence. I didn't mean to do that. I wanted to make sure that we went a specific direction, but in this case it doesn't matter. So we've got 1-chloral. Okay? So we've accounted for this. Now we have to account for these methyl derivatives. And again, those are on which numbers? Okay? So then we have to put 4, 6 dash, not just methyl. What happens when you have 2 methyl groups? You need a prefix on that. You need di on there. Then we need dimethyl. Now we've accounted for everything on this ring. Okay, I said 11 minutes. We ended up going to 16. But anyway, I just handed out their papers. You'll have time to work on that tomorrow. And also tune in tomorrow because we'll be reviewing, if you have your track meet, if you are having problems with this, I highly suggest that you tune in again tomorrow for our review. We will thank you for stopping. Okay, we will catch up to you next time.